Hi, this is Ed from Wright. Today we're here with CBQ in Greenzie, our partner in autonomous mowers. This here is our latest prototype of the autonomous mower, and I'm going to walk around the machine and show you, latest updates, how it works, and we're going to run it here in a minute. So first off, on the instrument panel, we've got the key, the PTO switch, choke throttle, normal components here, and then on this instrument panel here, you can see we're selected in the manual mode, and then when it's time to go into autonomous mode, we switch over here, and there's some buttons to select and program the mode. There's also an e-stop here, and there's a pendant that has an e-stop on it as well, which CBQ has here. And while we're looking at it, don't mind all the labels here, but these allow you to remotely control the machine. You can drive it around, steer it, and that's pretty fun actually. And then we've got engine functions and the autonomous mapping functions on there as well. And then the e-stop, which is important, so we're supervising the machine, and that's kind of a fail-safe type deal where hit the e-stop and the machine shuts down. This QR code loads the app, which loads some of the other handy information and resources that can be useful in running the machine. So if we take off the pad here, it's getting cleaner. We still have some wire lengths that are maybe a little longer than they need to be, but we're getting close in terms of the design. And what's going on here, we've got controls that go to these hand inputs here. So this is a drive-by-wire system with Hydro gear. And so these inputs from the hand controllers are talking to main machine controller, again from Hydro gear, and then this is driving the pumps. And so the pumps here have a servo actuator on the side of them here, and that's the drive-by-wire system. And that allows us to have a robust hand control system, controls the brake, the clutch, the starter, all these different functions. And then when it switches into the auto mode, then the computer can take control of the machine. And these two modules here, these two cartridges, we have a bunch of the input-output controllers and things like that. On the wheel, let's see if we can see that there, see that wheel with the flags on it. So it has sensors that can detect the wheel movement, and sensor for inertia. We got GPS. We've got the antenna for the pendant here. A lot of the machine is stock. It's significantly modified when we go down where the pumps are and where that box is there. But the base machine is a stock ZK. We have lights here which have different sequences and different meanings. And there's 6 cameras. So this camera is looking back towards here. We have one camera over here towards CBQ. We have one towards the front, another here, and another swept back behind this wheel. And then there's a camera on the back that's also observing, make sure nobody's near the machine. And then there's also these sensors here, which they have a closer proximity sensing. And the camera here is seeing depth with the 2 eyes in it, and can see how far things away are or whatnot. And so if you walk up the machine or the machine gets near something that is not identified, it shuts down right away, really fast. It stops, shuts the blade down off, and whatnot. And in CBQ, if you could, you're in early phases of going around obstacles right now. So you can get near something and it will begin working around it, and that's going to be something. One thing that's important to realize with this design and what we're doing here is that we're in the early phases of the whole system. The computer and all the hardware here, it's updated over the internet, and so you can push any kind of updates, and there's a lot of opportunity ahead as the software develops. And so like most of the things that we do, nothing's stagnant, it's always evolving. And then on this side here, there's a cellular connection, which is important for a number of different things. And in here we've got a computer that's doing the main processing. So did I miss anything?
Got it.
That's the main overview of the machine, some of the sensors, how it functions. Let's take it for a spin.
Let's do it.
Okay, so now we're going to walk through the sequence of things that you do in order to program the path and mow the machine. So we're running right now, we're in manual mode, the parking brake is on. I'm going to go ahead and record a perimeter. So now we're in map mode, so we're going to record the perimeter. now I'm going to switch into auto mode. We switch to autonomous mode. Now we're going to step back. And then we'll go ahead and hit mow. So what you're seeing right now is that there's particular waypoints that it has to hit. And sometimes it's looking for that first waypoint. And right now it's set up where when it does the pathing in CBQ, do you have a picture of the path here we can show? You can see the area that we programmed out. And can you show the lines? You can see that it's set the lines to the longest direction, so it's the least amount of turns for this property. And different properties may want to cut the lines different ways, but there's options in terms of which direction the stripes go. And default is going to run the longest direction. And you can see here, the corners, it's making the turns. Currently, the turning algorithm is slightly ginger, so you'll see it. Oh, it's making a perimeter pass first, right? So it's making a clockwise perimeter path, which gives it 2 passes to make the turns, and in a minute we'll see it making the turns. And there's some refinement going on right now in making the turns like really smooth. Every now and then, right now, it goes like past a waypoint and the turn continues to work itself out. So yeah, it's making the inside perimeter path. And then there's some other features in here. So right now, there's different speeds that you can go. So in heavier grass, you might set it to go to slower speed. In taller grass, you might set it to go faster speed. Yeah, a number of different options in here. And then I'm monitoring the machine here, so at any time I can hit stop, and we'll watch it make one more pass here.
He's doing his first strike.
Yeah, this is the first strike. There it goes. Yep. Perfect. So when it makes its turn and comes back, let's get in front of it and let it shut down.
Sure.
Demonstrate the obstacle detection. So there's those 6 cameras that are on it, and when it comes back, you'll see that the machine shuts down when it gets near it. So you can go around them. So I'm going to hit the E-stop, which shuts it down as well. That's a complete hard shutdown. So overall, that's how it works. We wanted to give you a little demonstration on that workflow, right? So how you record the path, makes the perimeter, and then it starts making the passes on the inside. Now, in terms of robotic machines and just where we are with that, this is one of our latest prototypes. We're going to be making a sequence of these different machines, and we call them pilot machines. So we're going to be doing a lot of validation, getting experience and feedback with them. It'll still be a while yet before we have a retailable product, but things are moving along. We're making good progress. Anything to add?
That's it. You nailed it.
Thanks.